I'm sorry for that delay. All right, so when we're doing these, when we're adding and subtracting rational fractions, that's a little bit different. So what we have been doing is 3 over 2 times 1/5. If I do 3 over 2 times 1/5, what do? I multiply my tops together and the bottoms. And I'm done. 3/10, and then I'll see if that reduces. That's fine. Now, what if I do 3/2 plus 1/5? You got to change the bottom to an LCD. And what is the LCD of 2 and 5? 10. So here's what happens. The 10 goes here, and the 10 goes here.
17.
So if I do 2 times what gave me 10? 5. So I put 5 times 3 to give me 15. And 5 times what gave me 10?
2.
So 2 times 1 is 2. And if I add those together, I get 17 over 10. Now, guys, this is literally what's happening. If I change 3 over 2 and I put a 10 there, well, 2 times 5 is 10, so 2 times 3 is 15. That's how I keep it equivalent. Are you with me? Now, how does that differ if I have this? What if I had 2/3 plus 4/6? What's my LCD there? 6. Because 3 goes into 6 and 6 goes into 6. So how did I get from 3 to 6? I multiplied by 2. So 2 times 2 is?
It can also be 3, can it?
No.
Because 4 or 6 would reduce to 2/3.
Oh, yeah, you're right. Let me change that, Tanner. Good point, Tanner. It's very smart. Very good. Oh, no. We're just going to start all over. What do I have? 2/3 plus, let's do 5/6. Thank you, Tanner. Now, what's your LCD between 3 and 6? 6. Can I do 18? Yeah, I could, but I wouldn't have the smallest. So how do I get from 3 to 6? I multiplied by 2. So I multiply my top by 2. And then how did I get from 6 to 6? I didn't do anything. I kept it, or I multiplied by 1. Either way you want to look at it. 5 times 1 is going to be 5. You got it? Now, when I put those together, I get 9 over 6. And then what does that reduce? 3 over 2. All right, guys, watch. This is the hard part. I'm going to show you a different way to do this problem. That's going to help you when I put letters in it. So if I do 2/3 plus 5/6, does everybody agree that that's the same thing as 2/3 plus 5 over 2 times 3? All right. What happens here is this. Do you see how the 2 and the 3 make a 6 when I multiply? And then here, I have a 3 and I have a 3. So my LCD would contain only 1 3. Why? Because if it already has it in it, then it's already a multiple of that number. So if I already have a 3 down there, it's already a multiple of it. But this number is also a multiple of what? 2. So what else do I have to have on the bottom with it? A 2. And then what's 3 times 2? 6. Now look, 3 changed from 3 to 3 times 2. What's missing on the top? So if I change this to 3 times 2, this would become 2 times 2. And then what's missing here? If I have a 2 and a 3 here and a 2 and a 3 here, did I change anything?
No.
So the 5 stays. So now 2 times 2 is 4, plus 5 is 9, over, again, 6, which will reduce to 3/2. Are there any questions about that? So watch this. What if I have 3 over x plus 5 over x?
8 over X.
Are the bottoms the same?
Yes.
So if the bottoms are the same, I can add my numbers on the top and keep the bottom. I do not put 2x. I do not put x squared. I put x. Are you with me?
And so,
So what if I had this? What if I had x minus 1 over 4x minus 5 over 4x?
X minus 6 over 4X.
Are my bottoms the same?
Yes.
So if my bottoms are the same, I put the tops together and keep the bottom. So what is my tops? X minus 1
Minus 5.
take away 5. Because I'm subtracting. And then what's on the bottom?
4X.
4x. What does the top simplify to be? X minus 6 over.
4X.
Can I reduce here?
No.
No, because I have a subtraction and the x's won't cross out that way.
Boom.
All right, let's see if you can do this one. If I have 2x minus 1 over x plus 2 minus 3x plus 2 over x plus 2.
2X minus 1 minus 3X plus
2x
2.
minus 1
Yeah.
minus,
3X plus 2.
what do you think I'd have to put there?
3X.
Why do I have to put parentheses?
Because it's one.
I'm not multiplying and I have a binomial, right? And I'm subtracting the binomial, not just the 3x.
Over X.
What is the bottom?
X plus 2.
X plus 2.
Yep.
Now let's clean up the top. So 2x minus 1. Go. Minus 3x.
Minus 2.
Minus 2. Why is it minus 2?
There's a negative.
The negative goes through it. Are you with me?
Yeah.
Over x plus 2. Now let's clean the bottom up a little bit more.
Bottom.
Or the top. What's the 2x minus 3?
Negative X. Negative X.
And then
Minus 3.
minus 3 over.
X plus 2.
Can I cross anything else out?
Negatory.
No, because they're addition and subtraction. Are you with me how we got those answers?
And or. Negative. Means positive.
All right, watch. Let me go back. Do you remember this? Shh. If I started out with 2/3 plus 5/6, then I had to get a LCD of 6, which is comes pretty natural to you. Look at this example one more time. If I broke this 3 and 6 down to 3 and 2 and 3, I only need 1 3 to make it a multiple. So my LCD was 3 and 2. All right, here we go.
Here we go.
Now, are my bottoms the same?
No. No.
Tell me what my LCD is.
X plus 2. X plus 1.
X plus 2 times X plus 1.
Yep.
Why?
Because you got to multiply to get the bottom.
I multiply them to get the bottoms the same. So if I have, what is the factor here? It's just like this one. When I had 3 and 2 here, I had a factor of 2 and a factor of 3. What's the factor here? X plus 2 and... So I have to have at least one of the X plus 2s. and the x plus 1. Are you with me?
Yep.
So that's one fraction plus, and then I have the same denominator, right? Are you with me? How did I get from x plus 1 to this one?
Times by x plus 1.
So I do 3 times x plus 1.
And 4
How did I
times
get
x
from this
plus
one to
10
this one?
Times by x plus 10.
Who has questions? Can I cross these out?
X plus 1 you can.
Sure, I can cross them out, but where would I go? If I crossed them out, where would I be?
3.
Right here. I don't want to work backwards. So now are my bottoms the same?
Yes.
So that would be x plus 2 over x plus 1.
X squared plus.
What would happen up here? I would put these together. Watch. 3 times x plus 1 plus 4 times x plus 2. Who has questions? Equals 3x plus 3
plus 4x plus 8. And then you got 7x.
x plus 2, x plus 1.
7x plus 11.
7x plus 11 on the top.
Over x squared plus 3x.
You can do that. You can leave it like that, though, as well. Who has questions?
Nothing.
Tanner's the only one talking to me. Who has questions? All right. Do not blurt the answer out. What is my LCD? Do not blurt the answer out.
It would be
Jordan, do not blurt the answer out.
yellow. I thought you pointed me when you flipped like that.
I am. Pay attention. Turn around.
If you're talking, I have to be looking at something.
Turn around. What you think, Lane?
X minus 1.
Is your LCD?
Sure.
Nope. Shh. Katie. Yes. Why don't I need 2 of the x plus 3s?
Because there's one on the right there.
Because right here, remember this problem? Did I need 2 3s?
No.
I just needed 1 because giving me 1 3 made it a multiple of 3. So giving me one of these makes it a multiple of that, and giving me one of these makes it a multiple of that already, so that's taken care of. Does that make sense?
Yes.
So my LCD would be x minus 1, x plus 3. I change both denominators to that. How'd I get from here to
It's the
here?
same
It's the same. All right, Monica, how did I get from here to here? Yes, you do. What changed? What happened from here to here? I didn't add 1, but I multiplied, right? So what do I do to the top, Savannah? If I multiplied the bottom by x minus 1, I have to multiply the top by x minus 1. And there it is.
Boom.
Tori, what do I do now? Over. And then how do I fix it, finish it?
4 plus 5x minus 5. And then 5x minus 1.
Who has questions?
Wait, do you put
Yeah.
the x minus 1 with the 5 because it's already with the 4? Like, because it's already under the 4? Is that why you put it with the 5?
You put it because you don't, did you understand this part?
Yeah.
Okay, So you change both denominators, right?
Mhm.
So when I did it here, when I changed this 3 to 6, this was easy to see because 3 times what gives you 6, you know that is a 2. But when I did it this other way, 3 to 3 times 2, I multiply by 2. So I multiply my top by 2. This one was 2 and 3, and so it didn't change. So I didn't multiply the top by anything. So on this one didn't change. This one changed because it became an x plus 3 to an x plus 3 times x minus 1. So I have to multiply the top by x minus 1. It's the one missing. So if I don't miss anything, I don't multiply anything. But see, this one to here is missing the x minus 1. So I multiply it by the top. All right, and there's your final answer. Who has questions?
Not me. Yellow.
All right. Let's look at that foldable. All right, you got your foldable, and you're reading step 1 is find the LCD. Step 2, multiply each fraction, and you can read those steps, so that's exactly what we just went over. So let's do one. Let's do example 1A. Here we go. You need to write this down on your foldable.
Oh,
M minus 3n over 6m cubed n minus m plus 3n over 6m cubed n. All right. I'm subtracting, so my bottoms have to be the same. Are they? Yeah. So I just keep it. If they're the same, I can go ahead and do the problem. Now, what does this become?
0.
No, it would not. No, it would not. M minus 3n. Write this down as I do. Do you see this minus?
Yeah.
You are subtracting the binomial. So the binomial becomes m plus 3n. So now, I have, does everybody understand why I have to put parentheses?
Yeah.
So m minus 3n, and then what do I do with the negative? So minus m minus 3n.
Negative 16.
Shh, Tanner. Who has questions there?
No.
What happens to my m's?
Go away.
M minus m goes away. What's negative 3n minus 3n?
Negative 16. Over 16.
Is that my final answer?
Can you cancel like
Yes.
Negative 5n
So
over
what would happen here is when you get here, what goes away? Because now everything's meshed together as multiplication, so the n's would go away. And 6's.
So negative 1.
Negative 1 on the top over m to the third.
Negative 1 over.
That's your answer.
Boom, shakalaka. Is that possible?
All right, watch. Let's do B. I have 5 over a squared plus 3a plus 2 plus 6a plus 1 over a squared plus 3a plus 2. Are my bottoms the same? Yes. So I can just go ahead and do it. So this would be 5 plus. Now, do I have to put parentheses around the 6a plus 1?
Yeah. can, you don't have to.
I can, but will it change the answer? No, because I'm adding.
Yeah.
So if I distributed positive 1, it wouldn't change anything. You should be writing this down. Now, do you understand why I'm just writing the bottom once? Because that's your LCD. It doesn't change. Now, what does the top going to become? Can we do this in our head?
6A plus 6.
6A plus 6. Questions?
That ain't the answer. Yeah, it is.
Oh, I think you're right. That's not the answer.
When you break down,
Oh, okay.
What?
6 and 3 ain't gonna have.
No. What could I do here?
Break down
The
factor.
6, I could factor. What factors out of the top?
6. A plus 1.
A squared.
That's it.
What does the bottom become?
A plus
A
1, A plus
plus
2.
2.
Oh, no.
Where did the
Look at that. Oh,
5
wow.
plus
A plus
1.
1 crosses out 6
Oh, right.
over A plus 2.
Yeah.
Does that make sense?
Yeah.
Boom.
Someone just asked where the 5 went. It's 5 plus 1 right there. That's how I got the 6. Do you see what happened there? Thank you for pointing that out. So what happens?
A plus 1 goes away.
What's your answer?
6 over A plus 2.
That was a sin.
Does the 6 and the 2 reduce?
No.
Guys, I have 2 minutes. Do not pack up. No, because this is an addition.
Oh.
All right. I'm going to skip 6 for right now. I want you to go to example 2. On your foldable, example 2. Let's do A. Now, you have x over x plus 4, minus 4, excuse me, plus 3 over x plus 5. What's your LCD?
X minus 4 and then X plus 5.
X minus 4, x plus 5.
Yeah.
So, do you see what they're doing there for you?
Yeah.
I don't like what they're doing on that foldable, but we're going to go with it. It's this. What's your LCD? X minus 4 and then x plus 5. So in that slot there that they have empty for you,
X plus 5.
put x plus 5, and then what goes right here?
X minus.
X plus 5. Block 4. Continue to watch the video. I'm going to keep going. Bye, guys. No homework.
Yay.
Okay, block 4. So, again, your LCD was x minus 4, x plus 5. On your foldable, it's putting x plus 5 in that blank. And then you have to multiply the top by x plus 5. So you have x over x minus 4, x plus 5, and then an x plus 5. In that next blank, they're doing 3 and then x plus 5 here. And again, your LCD, they're just putting the x minus 4 and showing you that you would multiply both. Now you have the same denominators. And then the bottom would become x plus 5, x minus 4, and then you bring everything over. So it would be x times x plus 5 plus 3 times x minus 4. And then you could distribute the top. So x times x is x squared plus 5x plus 3x minus 12, and you distribute the 3 over x plus 5, x minus 4. So the important part to remember there is if you have a binomial and you're multiplying, you need to put that in parentheses. Okay. All right, and then finishing this out, this would become x squared plus 8x minus 12. And then x plus 5, x minus 4. okay? And then this top, you got to make sure it won't factor. And in this case, it will. Well, we can try at least. So if I tried to factor that, it would be x and x. And then to get a negative 12, maybe negative 6 and 2. That kind of looks like it'd work because that's an 8, but it will not work because I have to get a positive 8. Then 7 and 4 won't work. So it's not factorable. So this would be your answer. All right. Now, the next example is the next example B says, give me 3 minutes, 3x over x squared plus 3x minus 10, and then minus 2 over x minus 5. So what you need to do here is you need to recognize that this could be factorable because it has an x squared in it. So before you determine the LCD, and you know that the LCD, they're not the same here, so you have to find one. But this one right here would factor into x and x, and then to get negative 10, you have to have 5 and 2, and to get a 3, it would be positive 5 and negative 2, and that would give me that. So now as you're looking at it, okay, what would your LCD be? Okay, and your LCD would be x minus 2, x plus 5, and x minus 5. Because I have to have one of these, I have to have one of these, and I have to have one of these. Okay? I'm going to do this problem with you when I get back. So let's just stick a pin in that for just a moment. Okay? All right. And that should get you started for the next lesson. Hope you made it to the end of this video. And I will assign homework on this very soon.